Hello, welcome to ETAP tutorial, Cable Thermal Analysis in Underground Raceway Systems, UGS. This presentation covers the following agenda. We're going to talk about cable thermal analysis fundamentals, how to create a new underground cable raceways in a docked bank system or in a direct buried system, add the cable to the raceway. Then we can show you how you can load the cable current and performing the thermal analysis and optimize loading current, cable sizing, transient thermal analysis, steady options, and finally we're going to show you some examples. There are different study options available. If you click on the brown suitcase from the top toolbar, ETAP gives you the menu for cable rating study case options. You can perform as a near MAGRA method or IEC 60287 method. Or also you can specify the initial steady state and based on the load profile or operating load of the cable. You can check and select to update the current from the ampacity calculation, or you can update the size of the cable based on the sizing calculation results. So if you uncheck this option as an example, if you run the sizing calculation with underground raceway system, the cable will not get updated unless you check this checkbox. There are two multiplication factors available in the study case, and you can apply it for the application multiplying factor, or you can use the growth factor. You can have it the growth factor per individual cable, or you can choose as a global growth factor. So if I choose 120, so all the cables that I have in that UGS is going to apply by this factor, so it will grow accordingly. Also, you can specify the transient temperature study, the maximum time or the maximum simulation time within period of 15 hours, or you can change it with how many minutes or days. And you can specify the output step size by entering the data. So ETAP will simulate or will calculate every single minute of this calculation. You can also perform different type of study cases, and you can run different analysis with respect to different study cases. So this drop-down list will show the available study cases in ETAP underground raceway calculation. The cable thermal analysis can perform and simulate like an electrical circuit. As you can see in this diagram, the heat flow represents like a current, and the heat thermal resistance shows like a resistance in this circuit. And the source of the heat is generated by the current passing through the conductors. And the difference between the ambient temperature and the conductor temperature, it shows like Tc minus Ta. This diagram represents a model for a heat flow from heat sources in a cable system to ambient temperature through a series of thermal resistances. As an electrical current flows through a cable, it generates heat. The type of a cable and how it is connected and installed determines how many components of heat generates are present. As you can see, the conductor, insulation, sheath, the other cables available in the conduit, and metallic conduit and other heat sources like steam pipes generates the source of the heat. And the insulation, the available filler or the air space between the conductors, overall jacket, air space in the conduit, the docked bank by itself, and the soil surrounded by docked bank represent as a resistance against this heat flow. And the temperature start to going from conduit to the ambient. ETAP underground raceway module capable of performing following calculations. Steady state temperature calculation. Also, you can perform optimizing cable loading current in two different methods as a uniform ampacity or uniform temperature method. You can perform cable sizing or you can perform transient temperature calculation analysis. ETAP complies with both standards as IEC 60287 or near Magra methods. The IEC 60287 steady state temperature calculation fully complies with the latest standards as listed here. In this tutorial, you will see how you can model the docked bank as an underground raceway system. As an example, you have a substation A, substation B, and there is a raceway number 1 running outside the substation A, and raceway number 2 get to substation B. And there is a raceway number 3 connecting to raceway number 1 through this manhole. And then you want to show the cross section AA, which covers the docked bank raceway number 1 and the steam pipe. And there is another cross section to cover raceway number 2 and cross section CC to have raceway number 3 and 2 together. Now I'm going to show you how you can simulate the cross section AA in ETAP. You can simply click on this button to go to the UGS mode, and the cross section is automatically shows up. As soon as you double click here, you can modify this to cross section AA, and this represent that cross section. Now you can drop the docked bank system from your right hand side toolbar, and it shows raceway number 1. You may resize the width or the height of the raceway from the graphic adjustment, or you can simply grab this corner to resize this, or you can simply relocate this to up and down. And if you wanted to change the number, you can modify it from here in the editor, or you can change the reference point, which is locating at this corner. As you can see, the depth of this docked bank is 15 inches. You can specify the Y, and you can specify the X, which is the distance from this corner to the left side of this reference. Now I can select the conduit from the right hand side toolbar, and I can drop it here, as many as I want. You can relocate the conduit graphically, or just simply double click on the conduit and change the horizontal distance and the vertical distance through the editor. You can insert the cable inside the docked bank raceway in 3 methods. Simply go to the right hand side toolbar and click on this button to drop a new cable, and you can double click on the cable, go to the library button, and you can select the cable if you want to. So for example, I want to drop the size 350 as an NEC standard cable, and you need to specify the length of the cable, and this is method number 1. Also, if there is a cable existing in your one-line diagram, you can click on this button as an existing cable. You can drop it inside the conduit, and now ETAP will ask you select it from the list. So I can select the cable number 3, which is existing in my one-line diagram, and as soon as you click OK, cable 3 is going to show up here, which is this cable. The third method, you can drag and drop the cable directly from one-line diagram. So in that case, you have to select the cable, press and control the shift key, drag it, and drop it. If you need to model the external source of the heat to your Raceway system, just simply click on the new external source. In this case, you can have it as a steam pipe. Call it steam pipe. And then you can specify the operating temperature and also the location of this. So the X and Y of this external source. In order to specify cable loading current in underground raceway system, one way is just directly enter the cable loading current to the cable editor. So in that case, I need to open the cable editor and go to the loading page. I can manually specify the average operating load current or per each phase, and this is called user-defined data. The other way is, for example, in this case, the loading shows 0 for this cable. I can utilize the load flow analysis if this cable is existing part of my one-line diagram. So I need to go to my one-line diagram, go to the load flow analysis mode, go to the study case and make sure this option as a cable load amp is checked to update. Now if I run the load flow analysis, you can see the result 572 amp passing through this cable 1, and now my cable 1 shows the same ampacity passing through this cable. Now I would like to show you how you can run thermal analysis for this underground raceway system. You need to click on this button. It takes to the calculation mode. And then by simply click on this button, ETAP will run the steady state temperature analysis as an iterative method. And ETAP will show you which cable reaches to the alarm, which cable goes to the warning temperature. In this case, cable 1 goes beyond 90 degrees and cable 4 goes beyond the marginal temperature. The alarm and warning temperature you can specify in the underground raceway system. So in this case, the ambient temperature is 35, the warning temperature is 88, and the alarm is 90. And the color is associated with that temperatures. In ETAP, you can optimize the cable loading current based on uniform ampacity calculation. Basically, in this method, with respect to the given cable size and temperature, ETAP is capable to find the cable current equally loaded based on hottest location reaching at 90 degrees centigrade. In this process, the approach is based on the equal loading criteria for ampacity calculation. ETAP will determine the initial loading level based on the base ampacity and then calculate the cable temperature in the steady state temperature calculation. Then we'll check the temperature value against the cable temperature limit. In ETAP, in order to perform optimizing cable loading current by uniform ampacity calculation, you need to be in the study mode, and you have to click on this button to perform the calculation. So if I, for example, look at this alarm temperature, which is 90 degrees, that means when I perform the uniform ampacity calculation, I expect the first cable reaches to the limit, in this case, which is 90 degrees. So if I run the uniform ampacity, so in this case, cable 4 goes to 90 degrees, and I can look at the result from the output report, and it tells me cable 4 with respect to 187 amp reaches to 90 degree, and the cable 1, for example, reduce it by 222 amp, and the temperature is 69 degrees. So all these cables reduces by the factor of 0.6 with respect to the derated ampacity. Now as another I can change the
alarm temperature. So if I increase it to 98 degrees and I rerun the uniform ampacity again, the new result, it tells me I can increase my current ampacity to something like 215 amp for the same cable. Now the hottest cable is going to be 98 degrees centigrade. The other option of optimizing cable load current is based on uniform temperature calculation. In this process, based on given cable size and temperature, ETAP will calculate and find the cable currents with respect to the uniform temperature for all cables. In ETAP, if I want to perform uniform temperature analysis, I need to make sure I am in calculation mode, and then if I click on this button in my right hand side toolbar, ETAP will perform, and all the cables in the docked bank Raceway system is going to reach to the limit, which is in this case is 90 degrees. So ETAP increase or decrease the internal current of this cable, and when I look at the result, as you can see, the temperature are very close to the limit, which is in this case 89.99 degrees centigrade, and I can see the current 319 amp for cable 1, 223 amp for cable 3, and 160 amp for cable 4. So if I go and change my limit, for example, I change the limit to 98 again, I can perform another uniform temperature ampacity, and I would get different result. And in this case, all the cables reaches to 98 degrees, and these are the new current ampacity: 199 for cable 4, 244 for cable 3, 343 for cable 1. When you perform uniform ampacity calculation for underground raceway, for some reason, if you don't want it to optimize some of the cables, there is an option in ETAP for each cable editor, which is called fixed current. Once you check this option, the cable current will remain unchanged for ampacity calculation for both uniform temperature and uniform ampacity calculation. Use this flag for the cable that do not require any ampacity optimization. ETAP underground raceway system also capable of doing cable sizing calculation. The cable sizing calculation determines the minimum size of each cable that will carry the specified load current without violating the cable temperature limit. This option is available in your vertical right hand side toolbar. As soon as you click on this button, ETAP will perform the calculation, and when you look at the result, it will tell you the new cable size. For example, in this case, it tells me cable size 2 odd is good for cable 1, and cable size 8 is good for cable 3, and cable size 2 odd is good for cable 4. And these are the ampacity available as I specified for this system, and these are the temperature, and none of them reaches to the limit. If you would like to change the cable loading current in order to resize the cable, you can simply go to the loading page of the cable editor and manually enter the new current available for the cable, and then click on the size button. Now if you look at the summary report, you will see now this report, it shows me size 2 odd is good for cable 1, size 2 for cable 3, and size 2 odd for cable 4. And these are the new ampacity which I entered to this cable. If you don't want to resize the cable for some of the cable available in your dock bank system, there is an option available in the loading page of the cable editor called fixed size. When you fix the size of the cable, after you perform cable sizing calculation, that particular cable will remain fixed and it doesn't change the size for the calculation purpose.
You can perform transient temperature analysis for underground raceway system. You need to go to the calculation mode and then simply click on this button to perform transient temperature calculation. By running this analysis, ETAP will generate the plots. So you can click on this button to open the plot for the cable that you have in the system. So if you wanted to watch more than one cable at the same time, press and hold the control button to multiple selection, and ETAP will show you the plot of the temperature with respect to that hour that you provided in editor. In order to specify the load profile for transient analysis, just simply double click on the cable and go to the loading page, and you can specify the load profile current in this table. By just simply inserting the button, you can provide the time and the current for that period of the calculation. The unit of the time could be second, minutes, hours, or days. So by default the option is hours, so you can specify the number of hours that you wanted to inject the current through the cable. There are different study options available. If you click on the brown suitcase from the top toolbar, ETAP gives you the menu for cable rating study case options. You can perform as a near MAGRA method or IEC 60287 method. Or also you can specify the initial steady state and based on the load profile or operating load of the cable. You can check and select to update the current from the ampacity calculation, or you can update the size of the cable based on the sizing calculation results. So if you uncheck this option as an example, if you run the sizing calculation with underground raceway system, the cable will not get updated unless you check this checkbox. There are two multiplication factor available in the study case, and you can apply it for the application multiplying factor, or you can use the growth factor. You can have it the growth factor per individual cable, or you can choose as a global growth factor. So if I choose 120, so all the cables that I have in that UGS is going to apply by this factor, so it will grow accordingly. Also, you can specify the transient temperature study, the maximum time or the maximum simulation time within period of 15 hours, or you can change it with how many minutes or days. And you can specify the output step size by entering the data. So ETAP will simulate or will calculate every single minute of this calculation. You can also perform different type of study cases, and you can run different analysis with respect to different study cases. So this drop-down list will show the available study cases in ETAP underground raceway calculation. Now I would like to expand my underground raceway to include the raceway number 1 and raceway number 2 and raceway number 3. So we know how to create the cross-section AA to include the steam pipe. Now I'm going to show you how you can create the cross-section BB to consider raceway number 2, and also how to generate the cross-section CC to have the existing raceway 2 next to the raceway number 3. So in order to generate the new cross-section, just simply click on this button and call the new cross-section or new presentation called cross-section BB. So ETAP will make a new cross-section, and if you wanted to insert the new docked bank, same as before, click on this button. So to insert the new docked bank, and you can call this raceway 2. So showing like this, and you can resize it again. Double click on the conduit to drop multiple conduit, to drop a cable inside the conduit. So now I have two cross section AA and BB. Cross section BB represent raceway number 2 and cross section AA represent raceway number 1. I can make another cross section for CC to join raceway number 2 and 3 to each other. So one more time, I need to click on this button called the cross section CC as a new presentation, and now the cross section raceway 2 is available, so I need to call it from the vertical right hand side toolbar, and all I need to just call this raceway number 2 and drop it. Now I have to drop a new cross section for underground raceway 3. So this is raceway 3 and this is raceway 2. So you can relocate it like this, and you can drop the conduit here. By double click you can multiple conduit, or double click on the cable you can multiple cable drop it on the system. You can simply go to the window and just do the tile, and you can see all the cross section AA, BB and CC with all the details docked bank to represent the entire of your composite underground raceway system. As you can see in this example, we demonstrate the huge docked bank with a lot of conduit and cables, and this example just to show you the capability of underground raceway ETAP to simulate the huge underground raceway system to handle and run the calculation, and ETAP capable of performing temperature analysis as well as cable current size optimizing and ampacity sizing as well.